Okay, geographers, we're going to do some more geoprocessing. And apologies, it's later in the day as I record this. I've got, like an office neighbor. He's discussing, I don't know, calculus or something with one of his students. Snooze sounds boring, but they're also being loud about it. So apologies if that's bleeding through students yakking outside of my office and all that. Hopefully, the audio won't be terrible. In fact, I probably shouldn't have even said anything. I probably should have just played it off. And if any students complain, it's like I think it's your speakers and go with that. But all right, whatever. We're gonna get this done. So I left you with the task of clipping everything to our ugly, blocky LA County boundary. All right. So as if you're watching this video, I'm expecting you've done all this and your map should look something like this. I've zoomed into the main county, not worrying about the islands. I cleaned up some, colors and all that just to make it look a little less garish and harsh. But I got my schools, I got my faults, I have the block groups, I've got the places, I've got everything clipped to LA County, and anything that isn't this clip stuff, I got rid of, removed it from there, right? So I wouldn't get confused. So that's what we're looking at here. Okay, that's what we got. This is where you should be. We're going to do just a couple of things here to see what we can do. And in fact, to kind of help with some of this stuff so we don't have so many things on here, I'm going to uncheck LA schools and the faults. So we're not going to worry about that yet. We will play with it, but not yet. I made the places just this hollow. All right, let's click on this real quick. So hollow meaning that the color gets this no color, this transparent quality, right? And the outline I made a 2-point gray um, uh, line outline around the thing, right? So that you can see through and so it doesn't mask other stuff. So I've got that and I've got these block groups. Now, this is not geoprocessing per se, but I thought we've talked about this. Playing around with the attribute table data, having the graduated colors and all of that. These block groups. In fact, let's zoom in. Let's just try this. We have some places these shapes in here. In fact, let's just go ahead and turn off places even. Some are bigger than others, right? Big areas of space here, and then tiny little things. And what these are neighborhoods that are created by the Census, the U.S. Census Bureau. The people who it's their whole job to, figure out how many people are in this country and where they live, and that's important from just understanding how many people we have, but also when it comes time to allocate certain resources, ensure that you have the right number of congressional representatives or whatever it might be for a location. And when we have population growth, that's big in saying like, do we need some new stuff in here, right? And that leads to new sources of funding and all sorts of things. So incredibly important. A lot of work goes on and a lot of GIS stuff. Just saying. I mean, it might not be the most thrilling work ever, counting people, but at the same time, it could be pretty cool. I don't know. I've never worked for the Census Bureau, so I'm not going to judge. I've worked in some places where people are ready to fall asleep hearing me talk about it, but it was actually cool. So just saying, they do a lot of GIS. But with these neighborhoods, these blocks, census blocks, the idea being that our individual data, like if I fill out the census, survey form and I say, okay, yeah, I live here and I live with my wife and my children and we live here and there are this many of us in this house. I don't want that information. I don't want all my personal information going out to you creepy GIS people, right? Knowing exactly where I live and how many of us there are and all that. So it gets aggregated. Okay, it kind of gets put together so it's anonymous and yet it's still accurate. That's the idea behind it. And if I click on any of these in here, very similar stuff to what we've seen and worked with, like that US population density map, right? But instead of looking at the states, we're looking at within a state. And in this case, within LA County, where are these people, right? So this is actually getting into a representation of actual population density. So as we go through, these are our fields in the attribute table. A few things to point out. The state FIPS, God, I'm blanking. I forget what FIPS stands for. But it's a code. The FIPS code is something the census uses. California is number 6. Okay, I don't know what 7 is. I don't know what 5 is. I just know because the majority of my work is in California, and the stuff I've done with government agencies, it's California. A FIPS code of 6, that's California. LA County is 037, 37, right? And the state and county FIPS 06037 means we're just talking about LA County within California. Not really important for what we're doing, but it is one of these things you see a lot of and could be useful. If I didn't want to do the clipping process, I could just select by attributes with some of the stuff that we've already done. I'd know, hey, I want 06037 in this field. That's going to get me LA County, California. Okay, so that's that. And we have the track, block group. It's all locational stuff. Once they continue, let me see. There we go. Expand this. We continue to have these little codes. And then we get into the actual population numbers. And it's a case with this, like we have the raw population, about 1,600 right here. The density per square mile is pretty close, right? It's not an exact number, but the idea is these blocks, when done properly, it's kind of a way of getting at density. So we don't need to worry about, the density so much with these. But you can still look at it and see how this works. This is also relevant. This is where looking at, different racial groups, age groups, sex, all this different stuff in here can be relevant to get a sense of where do we have certain people living, in LA County. Do we have a higher concentration of the elderly in one portion of the county, or a higher concentration of, young kids, right? If I need to figure out where we building a new school, this is that kind of stuff, right? Where do we have more little kids being born who need a school versus, people where, most people are over the age of 40 and it doesn't matter. So this is useful in here. So I just thought I'd bring this up because we're not going to do a lot of census stuff in this class. I don't think. I could change my mind, but it's just kind of cool to play with. And so we could change this again in Symbology. You just click not single symbol but graduated colors. It's going to do our yellow, orange, red horribleness. It's selected pop 2020. I can leave that there. I can pick something. Let's do this brown. It's just less harsh. But with this, you can really kind of see what's happening. And if you're familiar with the area, you get a sense of, yeah, this is a giant mountain range and forest right here. So it makes sense that we don't have a lot of people living in this area. You can kind of pick out different cities that exist, little urban centers. We can go, deeper into some of these places, get a sense of what's, actually there, where the big communities are and how it's laid out and stuff like that. So that's just based, again, on population. We can play around with other stuff. So that's there just to kind of again, see how we can do some visual analysis of where things are, what's going on, that kind of stuff. We could also, we could turn on these faults and start to get a sense of where are the faults that are running through heavily populated areas, right? Um, we could select out, let's look at our breakdown right here. So we could cut it off at something like, let's do 3,000. All right, let's get a population of 3,000. Let's see what this looks like. I'm making it up. Hopefully this will work. So let's do our query thing. We'll do properties and definition query. We want a new one. Let's do where pop 2020. And let's do, look, we're going to not do equal to. How about greater than or equal to? And we can have, it'll give us numbers in here, options. So we could scroll down and select that. But what did I say? 3,000? We can just, oh, it's desperate. Let's just chill. All right, buddy? So there, 3,000. Quit suggesting. So we'll do that. We'll hit apply. And I'm not even gonna be a coward. I'm just gonna go, okay. Boom. Right? So we can see in here where these more heavily populated areas are, and I've also got my faults running through here. Now the other things disappeared, so it's kind of hard to see the counting. It's why it can be night. Now that's a bit much. Let's tone this one down. That's a little less oppressive. So it's kind of nice to have that boundary thing just there as a container for things, just to make it look nicer. I don't really need it for what I'm about to do, but it's there. It's something. Okay, now with this, we can look at it and we can get a sense of, yeah, where these faults are and that kind of stuff. But let's do this. Okay, let's go to tools. And up here, I'll get rid of clip. And we are going to do intersect. Okay. So I'll click intersect. And so, yes, pairwise intersect is awesome. I'm sure I don't want it. I'm cool. Thank you. So with this, if I go to my little question mark help thing here, I've got two different layers. Okay. I can overlay with this. So it says it computes a geometric intersection of the input feature. So it means that with these features that actually touch, that intersect, right? I'm just going to grab those. And I being the computer in this case, right? That's what the computer is going to grab. So, oops, I forgot I can't show with my mouse. But you can see with the input, there's that little overlap thing. And then the output, it's just the areas that these things touch. That's the idea. Okay. So we can select multiple things in here. And with some tools, it's a case where you're limited with the geometry. Okay. A case where like it only works for polygons or it only works for lines or whatever. With this, I have all these options in here. So what I want to do, I want to do the block group and I want to do faults. I want to see where they intersect. And this is the cool thing is that, yeah, I can do a line intersecting with a polygon, or I could do two polygons or points or whatever it might be. And you note that with this one, it says use the filtered records. If I decided, you know what, let's do every single record, I would just uncheck this, right? But no, that's what I want. I'm not interested in faults running through places where nobody lives. I want to see these faults going through an area where there are people. What do I want to call it? Not this. That's kind of meaningless. But look. Okay, good. So my UTM, it's saving in the right spot. That seemed to take. But let's call this something meaningful. How about fault? I don't know. I don't want to say fault blocks because that's a totally different geology thing. Fault, and let's just do pop for populated areas. It's not my favorite name I've ever given something, but that works. Okay, attributes to join, all attributes, that's fine. We can leave that. Output type, same as input. Let's see what we got right here. Okay, so let's hit run. It's thinking, come on, green check, come on. Yeah, green check, we did it. And so what it spits out, right, are these lines, and it's purple in this case. So it's where they actually intersect. And that's its output type. I have a little bit of options, but not a lot. I can't really make a polygon when it's not two polygons coming together, right? So I'm kind of limited in what I can do. But if I zoom in up here, and I'm going to go and make these bigger. Hold on. Let's go this way. This, show it. Okay, it's a little bigger there. And I'll turn off this fault. So you see the red disappears from there because it's not intersecting. And if let's go ahead and turn this off. So I've got this strip of faults. And what happens if I click one of these? It says, okay, it's a San Andreas fault. That's a big one. From what I understand, kind of spooky. So we've got that. And if I scroll all the way to the bottom, yeah, here we go. We've got the fault information, but it's also combined that with our population stuff up here. So I know which track, block group, and all that stuff I'm talking about. I know in this area how many people actually live in this spot. So it intersected and brought these things together. Okay. And what I could do is this is all kind of convoluted. There are a lot of lines. Turns out some of these fault lines are not just fault lines. It's a bunch of interconnected faults, and that can be kind of confusing. So there are a few different ways we could kind of handle this. I don't need, like you see when I click on any of these, they're just little segments. Oops, hold on. Okay. There we go. Little individual segments. Might be the exact same, block group. I wasn't really paying attention to the numbers here, but that's something to be aware of, right? It looks like, yeah, there are a couple in here, but it's a lot. Maybe that's useful. Maybe it wasn't useful in that way, but I can get a sense of which areas in here do we have a fault running through, and we have people in this area. But let's try to make this a little more meaningful without going too crazy and overboard, because we've already been doing a lot of stuff here. So instead of doing it this way, let's do some different geoprocessing. Let's really take this to the next level. Go ahead and click on tools. And instead of intersect, I want buffer. Okay. The buffer tool. This is a good one. This one's useful. Let's go to our help. And so what it is we have our existing feature class. In this case, we're going to look at the faults. So we have our lines. Okay. Then we have a specified distance around it. 20 feet, 1,000 feet, 100 miles, whatever it is. We come up with it, and it will draw a polygon at that distance around the feature, right? This is stuff like, a lot of it, it's like creepy stuff, right? You can't be within 500 feet of a park or a school or whatever. Creepy stuff. This is how we could see like where people who, legally can't be that close to something could actually exist. We could take all the schools and all the parks, draw that buffer, and that's just like, no go zone, right? What we'll do here, to be less creepy, let's instead look at faults. And it's the idea that like you don't have to be touching a fault exactly to suffer from a big earthquake, right? So let's, instead of, just doing our lines here, let's do this. Input features. I'm going to do the faults. Output feature class, LA fault buffer. Now it's a case where it's saving in the right spot, but this name I don't like. This is what I do for all of my buffers that I do. I always put in at the end of it the distance. that I'm going to use. And for this, I'm going to go and let's just try 5 miles. So I'm just going to put 5 and then MI, click out of it. So I know, because sometimes, like, I'm just making this up right now. I'm just thinking, a general area around these faults. Let's see what it looks like. I might change my mind. I might think that's kind of big. Let's instead go to 2 miles. Or maybe I talk to the geologist down the hall and I ask her, like, 5 miles around a fault, is that, good to see kind of dangerous areas? And she says, actually, it has to be 10. Or no, do 3 or whatever. I go back in, I change the thing, I make sense of it. Okay. So I always just get in the habit of appending the actual distance to the end. And so down here, okay, I'm going to put in 5 and I need to make sure that linear unit, I'll keep meters. What is this, Europe? No, I want statute miles. That's what we'll use. And that too. I mean, I just mocked the metric system as my right as an American to do. But it is a case. Think about your audience, right? If I'm doing this for fellow geoscientists, it's going to be in the metric system, meters, kilometers, whatever. If I'm doing this for a governmental agency in the US, miles, feet, yards, that kind of stuff. If I'm doing it for the general public in the US, I'm going to do miles. If it's something I'm working on in Europe, I'm going to do kilometers, right? So just think about your audience there and pay attention to this stuff. These things we're going to leave for the most part, except here, dissolve type. I want to dissolve. And let's see. Dissolve features. Yeah, I'm going to do that. Because what I'm going to look at here, I'll explain what we're doing, but I'm going to look at it as a fault is a fault. I don't care which one it is. It's just if there's a crack in the earth and earthquakes can happen there, I'm going to treat it as the same thing. So dissolve all output features means that where we had, like near the San Andreas, where there are a lot of lines all overlapping here and kind of jumbled up, it's not going to make 18 different little buffers. It's putting it all together in one thing. Okay, it'll be a cleaner end result. So let's hit run. And we'll see. Come on, green check. Just thinking. Seems to be doing a little more work than usual. There we go. Oh, gorgeous. Look at that. Look at that. So these kind of blue transparent blobs out here, that's our buffer. And it also looks like, man, 5 miles. That is most of LA County, is what it looks like. But that is, that's reasonable, I think. Let's just leave it like this. I'm already tired. And I can see there are a few issues here too. Okay, this is good. Okay, so no, we'll skip that issue. We'll get into modifiable aerial unit problems and things like that later on. Something to look forward to. Some real nerd stuff. No, let's stick with this. Okay. So we got this here. Now let's go back to our intersect. And I can type it in here again. And remember, this is also with like the history stuff that I've used. I can go back and find it if I can't remember exactly which one I used or whatever. But this will work. Okay. And so let's do, we've got our LA faults 5 miles. Okay. And our block group right here. I'm going to keep that the same. The name, we already did that fault pop thing, so I can't do that again, but I can do fault pop 5 miles. All right, this time I also have a polygon and a polygon. So and that's, why would I do points in here? We're going to stick with same as input with this stuff because that's what I want. I want a polygon. Attributes to join. I can select some things in here. I don't it's not as useful as it could be. We're going to stick with all attributes. We got options, but not a lot of options. But we could always delete stuff later on or whatever. But I'm going to do this. Let's just hit run. All right, and I got stuff. I got a lot of stuff in here. Oh, look at this. Look at what it did. So let's turn off everything here. Okay, so it's given me these different things, and it's even used the same color convention, although it's different, right? Because you can see yellow in this one starts at 3004, whereas it's 0 for this one. So keep that in mind, right? We'll talk about that later on at some point, I'm sure. But in here, again, gives me that stuff, but it's also telling me the ones that are within 5 miles of these faults, right? So I could generate a report if I need to say, make sure that we have emergency supplies ready to go. We're actually making sure that we're studying, the seismic readiness of buildings in areas and stuff like that. We could look at this. We could target some of these places. We could work from the top down, right? Trying to do the most good. To start with, we find the places that are most populated, the more densely populated neighborhoods, target those first, then work our way out to the slightly less populated areas, and so on. Okay. So what we just did, you think about it real quick here, is that we went from, this hold on, is this this is the one. Why aren't you? Oh, because you dummy, hold on, let me turn off our query right here. Let's X that out. Yeah, I want to continue. Hit OK. So we went from this whole area, right, to this one, which if I change, let's do a single symbol. Let's make it big and scary. Danger, danger, danger. And apply that. Right. So now looking at this map, I've got, and I'll turn off Ugly County, but I've got, the whole place. And then I've got these dangerously, fragile areas with a lot of people living in there. Right. Kind of cool. Kind of cool that we were able to filter down to get some end result. So here's what I'm going to have you do with this work. What you'll turn in is a layout of something more or less like this. Show me the original census stuff. We won't even mess with schools. I think this I was going to look at what schools are going to crumble, but that's kind of dark. So let's instead show me the entire block group stuff for LA County that you clipped. Do this graduated color action that I did, however you want, and then intersect with a 5-mile buffer with the faults and the populated areas that are 3,000 people or greater. Get these results. Go to insert, layout. Give me something pretty. Give me a legend explaining what's going on. How about a north there? Throw in a scale bar, right? But turn in a map that shows me these dangerous areas, heavily populated, close to faults, right? Upload it when you're good, turn it in. It's going to be great. Show me what you got, geographers.